Hi everyone, welcome to my Lead Code Coding Challenge series. In this video, I will be presenting to you my own solution to the fourth question on the Lead Code website, which asks us to find the median of two sorted arrays. I will be implementing this algorithm using C#. Now, without further ado, let's go to leadcode.com website and see how I tackle this problem heads on. So come on in. Okay, so now we are on the Lead Code website where we need to tackle that problem. So this is the question. We are asked to find the median of two sorted arrays. They say given two sorted arrays nums1 and nums2 of size m and n respectively, return the median of the two sorted arrays. They give us examples here. They say example 1, nums1 is equal to this, nums2 is equal to this, and then the output is this, and then this and that, and this and that. So they explain it by saying you merge the arrays and then find that when you merge these two arrays, obviously the resulting array will be this one, and the median will always be this one, obviously, because as you can see here, this array, the number of items in this array is an odd number, it's 3, it's not even. Now when you come to the second array here, you see a slightly different scenario, because you have nums1 to be 1 and 2 and nums2 to be 3 and 4. And when you merge these two arrays, you're going to have an even number of items in the resulting array, which is 4. And to get the mean of a list of 4 items, to get the median of the list of 4 items becomes a bit difficult, in the sense that there's no outright number that divides the list into two equal halves, equal number of items on the left and equal number of items on the right, since we have 4 items total. So what you do in this case is, in statistics, in ordinary arithmetic or mathematics, what you do in this case is you add the 2 items that are in the middle and then divide by 2. So they got this by dividing 4 by dividing 2 and by adding 2 and 3 and divide by 2. 2 and 3 gives 5. Then you divide by 2. 2 times 3 gives 2 plus 3 gives 5. Divide by 2 gives 2.5. That's how they got this 2.5 here. Okay. So third example, you have nums1 which contains 2 items, and the values of those items are all zeros, and nums2 with 2 items as well. Because if you add if you merge these two lists, you're going to have 0 0 0 0 4 times, and when you add them up, you're going to get 0 divided by number. You're going to get 0, and since there are even number of items in the list, 4 items in the list, when you now get the 2 middle ones, which is 0 plus 0 all over 2, 0 over 2 is 0. Okay, that's how we got 0 here. Now, example 4, the first list is an empty list, and the second list it contains just 1 item. And then obviously when you get the mean will be the item on the second list, because the length of the list is just 1. So 1 out of 1 is 1. Okay. When you merge the two lists, you're going to get a list of 1 item, because this one is an empty list. The first one is an empty list. The fifth example, similar to the fourth example. The first list contains just 1 item and of value 2, and the second list is an empty list. So when you merge these two lists, you're going to have a resulting list which has just 1 item inside of value 2. So when you take the item, that will be the median of the list. Okay, so then we have these constraints here. We have this constraint here, which is informing us that the length of list 1 is m and the length of list 2 is n, and that m must not be, this expression says that m must not be less than 0, or the length of the list 1 must not be less than 0 and must not be greater than 1000. Okay, so basically no negative integers and no numbers over 1000. Same thing with the length of list 2. Okay, same constraint. Then we go to they are telling us that the sum of the length of list 1 and list 2 must not be less than 1 and must not be greater than 2000. Okay, that's what the expression is saying. Okay, and then we come here we'll see that they say the items, each item in each of these lists, whether list 1 or list 2, each item in each of these lists must not be less than minus 10 to the power 6 or greater than 10 to the power 6. Okay, this is basically what this expression is saying here. So let's go to the code now and see how I perform my own implementation. All right, then we're going to submit that and making sure it runs, and then it's accepted, and see how we rank on the Lead Code Challenge website. Okay, so we'll start by my own implementation of this algorithm. Now, one thing I want to do first, I want to make sure that list 1 is not greater than list 2, because you see, when we are calling this function, the function to find the median of the sorted arrays, this one, we are passing in list 1 in first position and list 2 in the second position. But if I find out that list 1 is greater than list 2, I want to recursively call that same function, but then passing in list 2 in the first position, and that is switching the positions of the list. Okay, so if I say if length nums1 dot length is greater than nums2 dot length, okay, if that is the case, let me put brackets here. We are not in Python, we're now in C#. Okay, if that is the case, I want to return the same function. Okay, return the same function and pass in, instead of nums1 and nums2, I pass in nums2, then nums1. Okay, yeah, this is what I want to do. Okay, I return that. Okay, so yeah, we do that. Okay, the length, it should be capital L and L. Okay, now I've taken care of that scenario. Okay, now I want to set variables that I'm going to be using in this solution. I understand that this is a sorted array. This list, each of these lists are sorted. So what comes into mind is okay, I need to use binary search, because binary search is the fastest algorithm to perform on a sorted list. So I have in mind that I need to use a binary search on this. So I need some variables to be used. So the first one I want to get is, I want to get the length of nums of the first list. Length of num1 is set to nums1 dot length, obviously. This is what I'd say. I can just copy and paste from here. Okay, save me time to type. Okay, and I copy this and paste. Okay, easy to copy and paste, but also easy to make errors. Okay, prone to errors. Copy and paste, prone to errors, but fast. Okay, in len nums2 is equal to nums2 dot len, obviously. Okay, what do I need now? I now need to initialize my low. To traverse a binary list using binary search, you need low and high. That is the start of search and the end of search. And I want to set the start of search will be the beginning of the list, and the position of every list is every list begins at 0. So my low will be 0 and my high will be the length of the list. Okay, so I will set int low. Oh no, still up there, don't go down. Okay, int low is equal to 0. Okay, the position 0, and int high, my int high will be equal to len nums1. Okay, yeah, So that's my int high. So then I say, then I begin to traverse the list now with my condition of traversing the list. Where do I get out of the list? Okay, say y, okay, y low is less than or equal to high. That's when it gets out of the list. What do I do there? Okay, I want to do a couple of things. I want to partition the two lists. First, let me partition the list one. So I say list one int partition nums one is equal to my low plus my high, and I divide that by 2, obviously, right? Divide that by 2, obviously. Okay, then I say my ints, then I get this one, then partition 2. Now partition nums 2 is not going to be the same like this one. No, it's not going to be the same. Would now be I'll get that. I'll get len nums 1 plus len nums 2, len nums 1, okay, plus len nums 2 plus len nums 2, okay, len nums 1 plus len nums 2 plus 1, let me see, plus 1, okay, they all that divided by 2, okay, all that divided by 2. Then I take away, oh no, I don't keep doing that like that all the time, I don't know why. Then I take away partition nums 1, okay. All right, so I'm adding 1 here to cater for scenarios where the number of items is an even number, okay. That's why I'm adding 1 there. All right. All right, now next I say, now I want to get the max left of partitions 1, and then I want to set the max left of partition 1. Now I partition, I want to get the, you remember when you partition, you have either you have nothing at the point of partition when you partition the list, at the point where you partition the list, or obviously when you partition you have left side and right side. All right, so now I'm dealing with the left side first. Now when you partition, either you have a number of items, 1 item, or number of items or 0 item on the left hand side. So I want to check for that, and I want to get the maximum item, the highest number of the numbers that are on the left hand side. Okay, so I call that, I say int, where my cursor there, I say int max left of partition nums 1 is equal to, I said, let's just instantiate that for the moment. Then I come here, I say if, okay, what I'm setting up here is the this one. Okay, I'm checking if this partition is 0 or has values in there, okay, so that I can then get the max length of the partition of the left hand side. So I'm checking if this left hand side is equal to 0. If the left hand side of the partition 1 nums 1 is equal to 0, I need to do something. If that is 0, I need to say partition 1 is equal to 0. I need to say I need to set partition 1, I need to set max value, max left of partition 1 to an infinite value. I need to set that to an infinite value. I say int dot max value, okay, that's an infinite value. Else what happens, else, is that else? That's not else. else, yeah, if that's the case, else I set it to nums1 index of nums1 index of partition nums1 minus 1 nums1 index of partition of nums1 minus 1. Okay, set it like that. So okay, so now we have sorted out the max left of partitions num1. Now let's get the min right of partition nums1. Okay, min right. So we've looked for the maximum number, the highest number on the left hand side of the partition of list 1. Now let's also get the minimum number on the right hand side of partition nums1. Okay, so we say let me just put this min int max nums1 and int min right nums min right of partition partition nums1. Okay, all right, so let's say partition here. I didn't write this well. Max left of partition nums1. All right, so let's just make sure we get everything there right. So this should be like this, max length of left must be equal to in dot max value. That's what I meant. There. Okay, this is equal to that, this is equal to that. Now we'll sort out the max left of partitions 1 nums1. Okay, so now we've set up the max left of partitions num1. So we've said if the partition nums1 is equal to 0, we want to set the max left of partition nums1, which is max left, as we said, the maximum, the highest number on the left of the partition num1. We want to set that to infinitive. Or if that's not the case, if partitions 1 is not 0, we want to set the max left of partition 1 to the index of the partitions, the partition nums1 minus 1. Oh, why didn't I write minus 1 here? Minus 1. Okay, that's the case. Now let's set the minimum right. We've gotten the maximum number on the left. Let's now look for the minimum number on the right of the partition, okay, of list 1. All right, so we have minimum right here. So we say if let's give space here so that we can be seeing where this if is. Give space here too. So we say if partition nums1 is equal to length nums1. all right, if that is the case, min right partition 1 is equal to int dot max value. Okay, else if that is not the case, if it is not equal to the length, if it is not equal to the length, we say else we set the this value to the index of partition nums1. okay, that is basically it. Okay, partition nums1, no partition exclamation mark. Okay, we do the same thing for list 2. We've done that for list 1. We do the same thing for list 2. So let's just say it here. let's just say list 1, and now we go for list 2. Okay, let's just copy this, paste, okay, and then make some little changes to go faster. Okay, so let's just say here we're dealing with list 2 here, so don't get lost on the way. So this will be 2 here now, 2 and 2. Okay, when did I make that? Oh, I think I did. I copied wrongly. No, this is not where I should put this here. Sorry, this is not here. Shouldn't be there. That shouldn't be there. It should be here. It should be here. List 1. So which means this one has to go off. This one doesn't exist here. Okay. Doesn't. List 2. Okay. So we have 2 here. That's what we're saying there. So this one goes in max left 2. Okay. So we put 2, the same thing here. 2, 2, 2, and 2 here, 2 everywhere, 2, 2, 2, 2, 2. Okay, we're just repeating the same thing that we did in the first list. Okay, that should do it. Okay, make sure we don't make error here. Just go through. Yeah, this one is done. This one is okay. This one is okay. This line is okay. All right. This line is okay. All right. Okay. All right. So if that is the case, if max left of partitions 1, where is it? Max left of partition 2. This is we want 1. I'll just copy the max left of partition 1 is a bit high up there. I don't want to go up there. So I'll just do it here and just change this to 1. The max left of partition 1 is less than or equal to min right of partition 2. Okay, max of min right of partition 2, min right of partition 2. If that is the case, take my head off there. It's disturbing. Okay, if that is the case, and that's our and there, and what? Okay, make another bracket there. Oh, we don't need bracket. No, we don't. And max left of partition 2 is less than or equal to min right of partition 1. So max left of partition 2. Let's just paste what we have there in the clipboard first. Min right of partition 1. That should be 1, and then say and min right of partition 1, min right of partition 2, but we say max left of partition 2. Okay, max left of partition 2, but 1 this time. 2 is less than or equal to. Okay, so if max left of partition 1 is less than or equal to min right of partition nums 2, partition nums, but that spelling is right. Okay, it's equal to 2, and max left of partition nums 2 is less or equal to min right of partition nums 1. Okay, close our what? Where did you close that one? Here. We just make one bracket there. Oh no, another one. Okay, now we go down, and then what do? So what do we do? If that is the case, we created. Let's create a list now. I'm going to create a list now and create and store in the max values, because I need to now get the maximum of those max values. So I said list of integers. Okay, list of integers. As a max list, I'll call it max list. Max list is equal to new list of integers. Call it max list again. New list of integers. I'm going to initialize that with the maximum values. So I'm going to pass on the max left of partitions 1 and the max left of partition 2. I'm going to pass the max left of partition 1 in that list, and because this is a list of max values, I want to get the maximum of those two values, and max left of partition 2, I want to get the maximum of those two values. Okay, yeah, it's too high up there, so we could easily cut it down like this. Okay, and let's take it that way. Take it a little bit there, okay. So list max list is equal to that, and then list min list. Let's create another list of integers as well. Call it min list is equal to new list of integers, and I'm going to also initialize that with the values of the min left of min list. We're gonna min right of partitions num1 and min right of partition num2. So I'm gonna do min right of partition num1. Well, this one's min right of partition nums1. And min right of partitions num2. All right. So these are my two lists that I have created. Okay. So cut this one down there. All right, we're fine there. Okay, that is the case. If that is that, I created this list, and what do I want to do? I want to get the max I want to get the max number. So max num, I will get a max number there. So the max number will come from this maximum list. So if I apply the max function on a maximum list, is going to return the maximum number between these two numbers, this one and this one. And if I apply the min function on this list, it's going to return to me the minimum number between this one and this one. So I say int max max is equal to max list. I could just do that there, up there. Yeah, let me just say int min is equal to min list dot max. Okay, passing the max dot min, sorry, not min dot min. Okay, now and then I can do now the max here. I didn't have to go down there. I can say here int max is equal to max list dot max. Okay, call the max function on it. Call the max function there. Okay, so that's what we have there. Yeah. If length nums1, okay, if nums1 plus length nums2, okay, is equal num1 2 mod 2, let's put bracket there. So we need another bracket here, another bracket here. So we need bracket there and there. Mod 2 is equal to 0. Close our bracket there. Okay. If that is equal to 0, return max plus plus min. Divide by 2. Max plus min divide by 2. So I should put another bracket here. I should say max plus min divide by 2, but we have to pay attention here. Listen here. The max is an integer, the min is an integer. We're adding the 2 is going to be an integer. So in a case where in the case where it is an odd number, it's not gonna return the integer, the decimal part of the response. Is gonna print out just the integer part. So our return will be false. Our answer will be false. So we need to cast this value into double. Okay. Because for example, see here, if we don't return, where's the example 2? All right, example 2, where the number of items in the list, in the resulting list, is an even number, and where there's no outright median that divides the list into 2 halves, equal left, equal right hand side. We need to take the 2 numbers in the middle and divide into 2, as we saw before. We need to take 2. We need to take 2 and 3. 2 plus 3 is 5. 5 divided by 2 is 2.5. But if we don't cast that into integer, if we just divide like that, we don't cast the return into a double, our return will be just 2, not 2.5. So to get the real value, and we get 2, our answer will be wrong. So if we get 2 instead of 2.5, will be wrong. So to get 2.5, which is double, because these numbers are integers, we need to cast that into double. So we come here, and this our response, we need to cast that into double. So to cast that into double, we just put bracket open and bracket close and write double there. Okay, that result will be cast now into double. Okay, so that's said. So we cast that into double. Then if that's not the case, if this is not the case, if length plus this mod 2 is not equal to 0, okay, so if it's not equal to 0, because means it's not an even number. What is mod 2 here? I didn't put 2 there. Why? So mod 2 is not equal to 0. So it's equal to 0. That's that. So if it is like this, means our resulting merge of those 2 lists is the number of items in the merge is an even number. That's why we are casting it, so that we make sure we are returning this. If it is not an integer, then we just return this. Okay, we just return. Return the max list, max list. Okay, dot max. Okay, we got to the max list dot max anyway. So say max list max. We just return max because already we just return this. Okay, just return max. Okay. It wouldn't matter then if we cast it or not, because it's an odd number. The median has an outright number that divides left and right equally, equal number of items on the left and equal number of items on the right. So it doesn't matter if we cast that into a double or not, but it matters if the number of items is an even number. In that case, we need to take the middle 2 and add and divide. And if those middle 2 don't give even number, all right, let's say the middle 2 are result to 8, for example, divided by 2, the median will be 4. We don't need to cast that. It wouldn't even matter. But what if it is not 4, as in that case the case we saw in example 2? If it is 5, then we need to cast that into double, so that we don't fall in a situation where our result is wrong. It returns 2 instead of 2.5. Okay. So that's said. So that's our return there. Okay, now then else here, this else of this if here. So else, so this return is for this if here. So we don't put else here because it just it's just return here, and so it returns. We don't need to write else there because there's a return statement there. So we come here, we say else on this if there, that big if there. Else, what do we do here now? So what do? We say else. Okay, else we check for we need to check to see if max length of partitions num1 is greater than min right of partition nums2. So if max length of partition num1 is greater than min right of partition nums2, min right of partition nums2, if that is the case, we want to set the high. That means we partition the list a little bit too far on the right, so we need to step back one step. We need to set the high one step backwards. So we set the high to partition nums1 minus 1. So we set that to partition. Where do we write that? We don't like to be copying all the time. Partition, I didn't write it anywhere, so it's right up there. Okay, partition nums1 minus 1. Okay, minus 1. Okay, we set that to that. Else, the final else now. Okay, our final else, we set low to partition where's our else? Okay, we set low to partition nums1 plus 1. We set low, which means we partition it too far back, too far back, so too early on. So we have to shift the partition a little bit further to the right. So to do that, we say partition nums1 plus 1. Okay, that's what we do there. Now then, okay, that's about it. So if that nothing works there, we just throw an exception. Okay, we just throw an exception. Throw new argument to a new argument exception. Okay, we just throw a new argument exception. Okay, well, all right, that's about it. So let's see. Let's see what we broke. And okay, so let's run it first. I'm just gonna clean the code a little while, so but just run it first and make sure it runs. Then if it runs, then we know we're fine. Then we come and clean the code. Okay, let's run it first. Okay, I'm not logged in. My code. Okay, comma expected somewhere. Okay, line 15. We've been missing a lot of semicolons. This is what happens when you spend time a lot with Python. All right. Okay, so what they're saying, come on, what is he saying about here? So let's make sure our brackets are okay. So we have this bracket here, it ends here. This should be minus partition. Okay. Okay, let's run again and see where the other errors were. Okay, minor. So we are down to 2 now. 1 is gone. So we need, yeah, we need another semicolon somewhere. So let's go again up there. Got it. Let's go up there. What is it? What is it? Why could that be? So line, what is it? Line 65. Line 65. All right. Okay, we are missing a semicolon here. So let's read it again. Okay, yeah. So we are missing a semicolon there. Obviously, another semicolon here. Let's run it again. Okay. All right. Now another crazy error. So what is it saying this time? Line 17. What is it saying about line 17? Cannot display index with array to an expression of type int in solution. So line, what's that? Line 36. Let's go to line 36 and see what is crying about. Okay. Line 36. What are you saying? All right. So okay, min right is equal to nums. This is the mistake we did here. This one, min min left of partition nums 1 should be oh my gosh, nums should be so we are on list 1, so it should be nums 1. So we are doing this one here, so it should be nums 1. Okay, let's run again, see where we mess up again. Okay, another error, line 17. We have a lot of errors. That's bad. When you're coming from Python, that's what happens. So now let's go to line. Let's see line 58. Character 17 error blah 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 expression int. Okay, let's go to line 58. Line 58. So what is it saying? Okay, same thing here. Same thing. All right. Okay, is equal to nums 2. Okay, that should be nums 2 partition of that, right? So let's go again. Okay, that's too much now. Okay, line 78. Okay, hi is equal to partition nums 1 minus what is it saying? So else if max line is equal to greater than, okay, if max line is equal to nums 1 greater than min right of partition num 2 partition, sure. Okay, there's spelling error there. Spelling error there. That's because of spelling error, right? That's spelling error. That should be. Let me see if this one is also that spelling error. Okay, let's run again and see. Okay, another spelling error somewhere, or what? What is it saying this time? Else partition. What are we saying? What am I writing here? Else. No, else. We are setting this to. We should say low. Low is equal to that. How can we just put it like that? Oh my gosh. Now you run. Okay. What else? Okay. Not yet. Not yet. Okay. System index of range index was out of the bounds of the array. Okay. So. So let's run it again and see. Oh, okay. Now let's submit our code now. See, we go through. Okay, we wrong. Okay, so it didn't work. So let's go over our code and see what we did wrong there. Yeah, so we're not returning. So see, look at the test cases. Okay, they input these two, and then this is what our program output Well, this is what was expected. So obviously our code is wrong somewhere. So let's see where we went wrong. Okay, so come here. While this is this, while this is that. Okay, I think everything there is good. If partitions number one this and this n dot max min value. Okay, if partition is this for list one, min dot max value, else is gonna be in dot min value, else it's gonna return min dot max value. Okay, now else this. Okay, now in partition 2, max, if partition nums2 is equal to 0, max of left of partitions 2 is equal to in dot max in dot no in dot, and then whoa. Okay, partitions num2 is equal to length of nums2. We're returning min right of partition is equal to in dot max value. We're also returning in dot max. No, this should be in dot min value. Okay. That should be in dot min value. All right. So let's already again make sure it's okay. And then okay, in dot min value. Then we check the code in, submit it, and see if we're gonna get it right this time. Okay. Okay, accepted. All right, successful. Okay, and then see, this is our performance. So okay, our code was accepted successfully, and the runtime is 120 milliseconds faster than 79.54% of C# online submissions for this median, or for this problem. Okay, so and we perform very well concerning memory management. So we use just 28.5 megabytes, less than 64.55% of this same submission. So our own code was fast, and it was very good at managing the memory. So all right, so this is about the this coding challenge. See you next for the next lead code coding challenge. Okay, thank you very much for watching. If you like it, hit the like button.